All right, this is the video for Concept 1 in your Unit 8 guided notes, which is the first unit of second trimester. And it's actually something that you should have seen first trimester, but it's really, really important. So I want to make sure that those of you who had it first trimester or even second trimester still remember how to do it. And if you never learned how to do it, then now's the time to learn how to do it. So this is, I call it the factoring prep review because we're not actually technically factoring quadratics yet. We'll do that in concept 2, but we need to be able to do all of these things so that we're able to factor quadratics. So the first thing we have in our notes is standard form of a quadratic. So the standard form of a quadratic basically says that we put our exponents in from biggest to lowest, or in descending order. So notice right here we have the x squared first, and then just the x, which would be like x to the first, and then no x at all, which would be like x to the 0. So technically our exponents are going 2, 1, 0. So we're putting them in descending order, and if we had a polynomial with x to the 5th, then we would go x to the 5th, then our x to the 4th, then our x to the 3rd. And that's the same, obviously, whether we use an x as our variable or if we use an n or a g, or it doesn't matter what we're using as our variable. So with these first 3 problems right here, we're going to go ahead and put each of them into standard form. But as we can see up here, in order to do that, we need everything to be on the same side of the equal sign. So if I look over here, I have 3x and a 5x squared, but I need my 7 over on that side of the equal sign. So to do that, I'm going to subtract 7 from both sides. And then I'm going to put these in order. So I need the x squared first. So I have 5x squared. And then my 3x is positive, so plus 3x. And then I had to minus 7 over, so minus 7. And then to list A, B, and C, it's just the number part. So sometimes I will have people put A is 5x squared. Don't do that. We just want the number that's in front of x squared as shown up here in standard form of a quadratic. So I start with A is 5, B is 3, and then C is a negative 7. So your sign does carry with you. So this is a positive 5, a positive 3, and a negative 7. Hint, as we look at number 2, whatever your x squared term is, you want to be positive. So in this case, instead of minusing the 2x from both sides and adding the 6 over, I'm just going to go ahead and add 4x squared to both sides so that my 4x squared will be positive. Your life will be infinitely easier if your x squared term stays positive. So then over here I have my 4x squared first, that's now positive, and then a positive 2x minus 6. So my A, B, and C is 4, 2, and negative 6. And then number 3, this x squared's already positive where it is, so I'll go ahead and move the 2x over. So I have x squared minus 2x minus 9. So when I go to list my A, there's no number in front of the x squared, but that just means I only have 1x squared, so my A is 1. So don't get confused and put an x or an x squared here. There is still a number there, we just don't write it. So my A is 1, B is a negative 2, C is a negative 9. So that's the first step to being able to factor, is to make sure that you have your equation in standard form and you know what A, B, and C are. One of the next most important things when it comes to factoring is being able to factor out the greatest common factor. So a greatest common factor is a number and or variable that can go into every term in my quadratic or in my polynomial. So a term is just something that's separated by a plus sign or a minus sign. So this is one term, this is another term. Or over here, this is one term, another term, another term. So we want a number that goes into each term in our given quadratic. So on number 4, we're going to start by looking for a number. So I have 2 and 10, and the number 2 goes into both 2 and 10. And then I have an x squared and an x. So x goes into x squared, and an x. So when we factor something out, in essence what we're doing is simply dividing it. So if I were to do 2x squared, which I can rewrite as 2 times x, because x squared is just x times x, and divide that by 2x, all I have left is an x. So if I take a 2x out of 2x squared, I have an x left. Versus if I do 10x and divide that by 2x, I have 10 divided by 2, which is a positive 5. So this factors to 2x times x plus 5. So basically when you're factoring something out, you're dividing it from each term. So let's use that same idea on 5, 6, and 7. Number 5, I have 12, 3, and 6. So the number 3 goes into all of those numbers. And then I have an x squared and x, but this doesn't have an x attached to it, so I can't pull any x's out. So I'm going to go ahead and do my dividing. So 12 divided by 3 is 4x squared. Negative 3 divided by 3 is a negative 1x, which is the same as just a negative x. And then 6 divided by 3 is a positive 2. So now I've factored out the greatest common factor in that one. And then 6 and 7 are the exact same idea. So I have 5, 15, and 10. I can factor out a 5 of all three of those. But again, my 10 doesn't have an x, so I can't pull an x out this time. So 5 divided by 5 is just 1x squared. Negative 15 divided by 5 is negative 3x. 10 divided by 5 is 2. And then on number 7, remember there's no number here, so there's just 1x squared. So with 1, negative 2, and 7, the only thing that I can factor out is a 1. And if I divide each term by 1, each term stays the same. So most of the time, this isn't really necessary to do, factoring out a 1, because it leaves our quadratic the same. However, there are some parts of factoring where factoring out a 1 is useful, so make sure you know how to do it, and I'll talk a little bit more about when to do it a little bit later on in your notes. So this is how we factor out a greatest common factor. So now you should be able to write a quadratic in standard form, state what a, b, and c are, and factor out a greatest common factor. So then our next section asks us to list what a times c is, what b is, and then find two numbers that multiply to ac and add to b. So that sounds probably a little bit more complicated than it is. So I already know from above that this number is my a, this number is my b, this number is my c. So a times c is just 3 times 4, which is 12, and my b is a negative 7. So that part's not too difficult. The next part asks us to find two numbers that multiply to AC, so that multiply to this and add to B and add to this. So two numbers that multiply to 12 and add to negative 7. So this part comes differently to different people. Some people are pretty good with their multiplication facts and they can just look at it and think, oh, those two numbers, multiply to that and add to that. But for some of us, it's a little bit more difficult than that. So one way that you can think about it is to just start by looking at what we need to multiply to. So we need to multiply by 12, and then just go one number at a time. So 1 times 12 is 12, but 1 and 12 aren't going to get to 7. 2 times 6 is 12, but 2 times 6 isn't going to get to 7. 3 times 4 is 12, and 3 and 4 could get to 7. So now I'm thinking 3 and 4 should probably work. And if they're positive, 3 times 4 is 12, so that works. But 3 plus 4 is a positive 7, not a negative 7. So I'm probably going to need some negative signs in here. But in order for it to multiply to a positive 12, they both have to be negative. So a negative 3 times a negative 4 is a positive 12. And then a negative 3 plus a negative 4 is a negative 7. So those are my two numbers. So you can kind of do it whatever way works for you, but if you have a hard time thinking of it, that's an organized method to do it. Start with 1 times 12, 2 times 6, 3 times 4, and keep going until you have two numbers that work. So if I look at number 9, again with no number here, this is just a 1. So 1 times 16 is 16. So notice that when your a is 1, your a times c is the exact same thing as just your c, because if you multiply this by 1, it's going to stay the same. And then your b is 8. So two numbers that multiply to 16 and add to 8. 1 and 16 doesn't work. 2 and 8 doesn't work. 3 doesn't go into 16. 4 and 4 does add to 8. So 4 and 4, I'll go ahead and put a comma over here. 4 and 4 add to 8, multiply to 16. Then number 10, 2 times 6 is 12. My b is 8. Two numbers that multiply to 12 and add to 8. 1 and 12, no. 2 and 6, yes. So 2 and 6 multiply to 12, add to 8. So the last concept that you need in order to factor quadratics is to be able to factor by grouping. And for the purpose of this class, we're only worrying about quadratics, but you can also use this when factoring higher degree polynomials, which you should learn when you take Math 3. But in our case, we're just worried about quadratics. So this is the process of factoring by grouping. The reason we call it grouping is because the very first step is you're going to group your first two together and group your second two terms together. And then we're going to do a thing that you've already learned and pull out the greatest common factor of each group. So I'm going to start by just looking at these two, and this is a 1x squared. So I can factor out a 1, is all that I can factor out of those two. And this is where factoring out a 1 is useful. So when you're factoring by grouping, if you can factor out a 1, factor out a 1. And then x squared and x, they both have an x, so I can also factor out an x. So if I factor out a 1x, x squared, take out 1x, I just have an x left. 5x, take out 1x, or divide out 1x, and I just have a 5 left. And then a little tip for you, just like when we're putting things in standard form, we don't want our x squared to be negative. We move it to whatever side we need to move it to make it positive. That's the same thing with our front terms when we factor out a greatest common factor. We don't want this x to be negative. So when I look at 3 and 15, 3 goes into both of those numbers, but in order to make my x positive, I'm going to pull out the whole negative 3 instead of just a 3. So then I'm left with just an x, and then negative 15 divided by negative 3 is 5. Notice now that my parentheses are the same. They both have x plus 5. If your parentheses are not the same, then you've made a mistake and you need to go back and relook at what you've done. So now that my parentheses are the same, I'm actually going to factor out the whole parentheses term. I'm going to take out my whole x plus 5. So now these are gone, and I'm left with 1x, or just x, minus 3. So now this is factored from the step where it's already the middle term has been split. So factoring by grouping, that's the basic process. So let me show you at least one more time. I might show you 13 as well. So group the first two terms, the greatest common factor, so I can pull a 2 out of 2 and 6, and I can pull out an x, because there's an x squared and an x. And then I'm left with x, and then minus 3. And then over here, I can pull out a 4. And this time I'm going to pull out a positive 4 because my x will stay positive. And then negative 12 divided by 4 is a negative 3. So my parentheses match again, so that's a good sign. So I'm going to take my parentheses term, which is x minus 3. So I took care of those. And then I'm left with 2x plus 4. So my second set of parentheses has a 2x plus 4. And if I were to FOIL this, if you use the term foiling, or distribute this as my preferred term, so if I did x times 2x and x times 4 and I multiplied this back out, I would get exactly this. So basically we're distributing but backwards. So let me show you one more time on 13. So I'm going to group these two terms, group these two terms. So on this side I can factor out a 2x, and I'm left with 3x minus 4. And on this side, the only thing I can factor out is a 1. But like I mentioned on number 11, in this case, that is something you want to do. So if I factor out a 1, then my 3x minus 4 just stays the same. So 3x minus 4 is my first set of parentheses. And then I'm left with 2x plus 1. This is why it's so important that you factor out that 1. Otherwise, I would just have a 2x, and I wouldn't have this plus 1, which doesn't work. If I were to multiply that back out, I wouldn't get back to here. So these are all of the basic skills that you need to be able to factor, and this should help you be able to do everything you need to do on your assignment. So go ahead and make sure that you do your 8.1 assignment if you haven't already. And that is everything for Concept 1 of Unit 8.